You don't like refried beans or like
oh my
brown
gosh,
beans?
refried beans.
Really?
Regular beans, a little bit of my vegetables, but
Okay.
Refried beans with like shredded cheese on top is good.
Oh,
Yeah,
it's
yeah,
so good.
Like at Taco
Yeah.
King?
Yes,
Oh.
yes.
You put your rice like on
Yes.
the beans.
Just like thinking about the texture in my mouth makes me want to vomit.
Wow, wow.
It's like pudding, but it's beans. That's
It's warm.
Just out of curiosity, who is I like refried beans. Like I would like those. And who's like I don't want anything to do
oh
with it.
my goodness.
Okay. All right. So 3 of the people in my family they really don't like them, and then 2 of us do. So if we go out and like get Plaza, get a chimichanga, right, with some fried
Double
rice and
double
beans.
rice. Oh.
So yeah, double rice is
I had
what 3 of them
Plaza
choose.
yesterday.
Okay, double rice. Yeah, so that's what the other 2 or 3 in the family do. But me and my son, we like the beans.
Yeah.
Especially throw some
They're
cheese
really
on
good
top.
for you, but.
Yeah, let's go. You know what else is good for you? Solving trigonometric equations. It is so healthy. It cleanses the brain, puts you at one with the rest of the world. And we're going to start off with this unit circle here. We got a coordinate over here of 1, 0. We got this coordinate of 0, 1. This coordinate of -1, 0. And down here at 0, -1. And I'm only going to put 3 more points on here. Let's see if you guys can tell me what this coordinate right here is. Square 3 over 2 and 1/2. Very good. This one, obviously, everybody knows is root of 2 over 2 and root of 2 over 2. And this one up here, we've got 1/2 and the root of 3 over 2. By the way, seniors, get signed up for that senior dinner dance. It's usually a fun time on a yearly basis.
That's so expensive though, like for no reason.
Is it?
Wait, are you talking about the
$40?
What are you talking about?
$40. I don't know. I went
For pasta? Is it like the
because
pasta?
I went to Jersey Mike's the other night and I got a sub for me and Mr. Luther and a pop and stuff, and I spent $30 at Jersey Mike's. So I'm like, it seems a little bad. But if you have a problem with the expenses, you could talk to somebody downstairs and they'll help you out. Sine of x is equal to 0, okay? So we're going to solve the most basic of equations. And then after we solve these equations, we're going to try harder ones. When is sine equal to 0? When is sine equal to 0? Sine the x value or y value? When is y equal to 0?
So on the x-axis.
Right here
Yeah.
and over here
Yeah.
and then back over here. So we got 0 degrees. So x equals 0 degrees, x is equal to 180 degrees, and x is equal to 360 degrees. Sine of x equal to 1. I'm looking for a y value of 1. That happens at 90 degrees. In this unit, we will be not collecting money for the dance, but what we will be doing is we'll be solving for angles between 0 and 360 degrees all the time, okay? We're going to keep it between 0 and 360, and we're going to work with degrees. We will, we'll work with degrees. We will not work with radians. We're not going to do radians, okay? Stick to degrees between 0 and 360. Where's sine equal to -1? Yep, down there at the bottom, that's where we have a y value -1. Now let's switch it to cosine, okay? Switches when we get to cosine. When is cosine equal to 0? That's the x value, right?
90 and 270.
Yep, very good. 90 degrees and 270 degrees. And then we got when is cosine equal to 1? The x value is 1 right over here at both 0 and 360. So when is cosine -1? 180. So sometimes you can kind of just picture those in your mind, can't you? Because they're nice spots in the unit circle. What if we switch to tangent? Tangent is the y value divided by the x value. And notice if we check out tangent, if we take y divided by x, we get 0 here. But what do we get up here at 90? Undefined. So tangent is equal to 0, at 180, and at 360. Tangent is equal to 0 at 0, 180, and 360. How about tangent equal to 1? That's different. It's not on one of the axes. We have to think about when is the x and y value the same? 45. There's also another spot where the x and y values are the same. Where is that? 225. They're both negative. So then number 9, we have tangent equal to negative 1. That's where the x and y values would be opposite, which would be? Yep, 135 and 315. Good job. So we'll make things just a little bit more challenging. We're going to do this one together right here, but I want you guys to try these two on your own, or I'm sorry, with a partner, see if you can come up with those solutions. Hint, there's 2 for each one, see if you can come up with them. Think through it. Think about quadrants. Go ahead.
Oh, wait, no, it's negative.
Oh, sine.
330. Isn't sine the y value?
Yeah.
Yes, it has to be down below, not the other way.
Yeah, you're right.
It's still
So it has to be
positive.
in the third and fourth quadrant.
Oh, you're right. So it'd be.
220? Yeah.
That's not.
Serious?
Is it?
Oh, yeah.
So the sine, it's all gonna be below these two quadrants.
Is it these two?
So it's gonna be 210.
No. Yes.
And then it's gonna be 30 minus this one. And then this one's cosine.
So that would be.
So cosine is x, so.
The other negative 150
Okay, I'm going to transition to show you guys a process. We're going to use our calculator a lot in this situation as we move forward. But one thing hopefully you understood is that if sine is negative, then your answers are going to be between 180 and 360. And 1/2, maybe you thought about this whole like 30-degree angle thing. So when does it make a 30-degree angle? Well, that's going to be at a value of 210 and a value of 330. So our values are x equal to 210 degrees and 330 degrees. And the same thing happens for cosine. Your answers are going to be 150 degrees and 210 degrees. Well, you get to an example like 12, and that's kind of where we pick up with, teaching you. You guys have the foundation, and now it's time to kind of go through the process. When we see tangent, sine, or cosine equal to something, first we decide whether it's positive or negative. Is my tangent value positive or negative? When is tangent negative? Which quadrant is tangent negative in? 2 and 4. So I draw reference angles in the second quadrant and the fourth quadrant. A reference angle is an angle against the x-axis. So what I want to do is I want to put a reference angle there and there. The way I calculate the reference angle is I go to my calculator and I type in second tangent, and I don't type in the negative, I just type in the positive. Never type in the negative, always type in the positive. You use the negative up when you determine the quadrants. I press enter, I get 63.43. So here we are at 63.43 degrees. So I will use that to calculate the angles. This one is 63.43 back from 180, also known as 116.57. And then the next one is 63.43 back of 360, which brings me to 296.57. And those are the two solutions. Yes?
How did you get the 63.43 again?
I went to my calculator and I said tangent inverse of 2. Never use the negative, only use the negative to determine the quadrant that you're in. Press enter and I get 63.43. So make sure you're working in degrees and not radians. Okay, flip it over and we'll try them from there. Okay, so these are what your problems are going to look like when we first start. They do get more challenging when you come back from break. But what will we do to both sides for number one? How would you start that problem out? Yep, we're going to add 1. And we get 2 sine of theta is equal to -1. We divide by 2 to get sine of theta is equal to -1/2. Now, once again, we just encountered this on the other page. And we looked at our quadrants. Sine is negative in which quadrants?
3 and 4.
So you make 3 and 4 for reference angles, and we plot 30 degrees. If you inverse 1/2 on your calculator, you get 30 degrees. And you can see from our previous problem that that would be that theta is equal to 210 and 330. So notice how you were able to think about it before, and now in this situation you're able to use a process. So for number 2, we solve it very similar. We add 4 to both sides, and we get -5 cosine of theta is equal to 2. We divide both sides by -5, and we get cosine of theta is equal to -2/5. In which quadrants is cosine negative?
1 or 1, no, 2 and 3.
2 and 3. 2/5, that's not a value I'm familiar with. So I go to my calculator, and I do not type in cosine inverse of -2/5. I always use the positive. Don't use the negative. And I get 66.42. My first one I subtract from 180, and I get theta is equal to 113.58. And then the other one, I get 246.42. And those are my two
How do you know what to subtract it from?
Good question. Part of it is to just recognize that that's 90, that's 180, and then that's 270. So you're going to come up with an angle between 180 and 90. So you're going to have to subtract from 180. Whereas the next one, you're going to come up with an angle between 180 and 270. So you add to 180. Does that help a little bit? And you're never using 90 or 270 for the addition or subtraction because those are not on the x-axis. Try number 3 on your own. Check with the partner when you get done. Is it 5313?
Mm-hmm.
So my two solutions, first and third quadrants. Very good with that? Question going once? Twice? Twice. How about number 4? Looks a little bit more complicated. Where would you start?
-3.
Subtract 3. What else could you do?
Distribute.
Distribute? Yeah. Subtracting 3 works fine. I am going to choose to distribute right away. And then we'll combine our like terms after that. We'll distribute the -3 and the +2. And I get -6 cotangent of theta there'll be a plus 3 is equal to 6 minus 2 cotangent of theta and minus 1. I now look for my terms to combine. I have the 3 and the 3, and I have the 6 and the negative 1. So I'd have negative 6 cotangent of theta plus 6 is equal to negative 2 cotangent of theta plus 5. So I got cotangents on both sides. What do you think I do? Yeah, just add them on over, just like it's an x. Very good. So I'm going to add the 2 cotangent of theta over the other side. And I get negative 4 cotangent of theta plus 6 is equal to 5. I subtract the 6, I get negative 4 cotangent of theta is equal to negative 1. And I divide by negative 4 to get cotangent of theta is equal to 1/4. And that's where I've got a problem, because I don't have a cotangent button on my calculator. Yeah, instead do tangent, right? Just flip it upside down. And let's not solve that. I think we've done enough. Can everybody agree that you would know how to solve it from there? Okay, so let's pause there to save some time. In this situation, next one, I'm going to gather the cosecants to the same side. So I subtract 3 cosecant. And I get 1 cosecant is equal to positive 3. Again, I don't have a cosecant button on my calculator. So what do you use instead? Use sine. Sine of x is equal to 1/3. And we would obviously be able to solve from there. Number 6, we add 3 to both sides. We get 11 cosine of x is equal to 17. And we're dividing by 11. Cosine of x is equal to 17 over 11. You may notice something a little bit interesting about that. (17/11) is bigger than 1. Can cosine ever be bigger than 1?
No.
No, if you think about the sine and cosine graph, they always bounce between what 2 values? 1 and negative 1. So if you try to inverse cosine of 17/11, you would not get a solution. There's no solution here. What's different about number 7? It's a squared. That doesn't scare us. We know what to do. We're going to start by subtracting 1 from both sides. And we get 3 secant squared of theta is equal to 12. We divide by 3 and we get secant squared of theta is equal to 4. I'll square root both sides and I get secant of theta is equal to, notice that since you're doing the square root of a variable, you must list the positive and the negative, plus or minus 2. Flip it to cosine. Cosine of theta is equal to plus or minus 1/2. So we've got a plus or minus. So as you think about your quadrants here, we think about where is cosine positive. In which quadrants is cosine positive? 1 and 4. And where is cosine negative?
2 and 3.
2 and 3. So that means that we have how many solutions? You have 4 solutions. If you inverse 1/2 on your calculator for cosine, you all know that you get 60 degrees. And so we write the 60s right in those spots. Always against the x-axis, never against the y-axis. And so theta is equal to, the first value will be 60. What is the next value going to be? 120. And then? 240. And then 300. Very good. Three more problems, you'll be done with quarter 3 trigonometry. Wow, still got a test, but you get my point. How about number 8? Let's get to some trickier stuff. What about number 8? What would you do first? You got 2 tangents. Starts with F, rhymes with actor. We're going to take out a tangent. And when you take out a tangent, what are you left with?
Tangent plus 1.
2 tangent of theta plus 1. So now we have 2 equations that we're solving. The first one I'll write in red. The tangent of theta is equal to 0. And the other one I will write in black. 2 tangent of theta plus 1 is equal to 0. Do you remember from us talking on the previous sheet, do you remember where tangent is equal to 0?
0, 180, and 360.
Excellent. 0, 180, and 360. So you have 3 solutions for that part. And then for our next one, we're going to subtract that 1 to get 2 tangent of theta is equal to -1. And then we're going to divide by 2 to get tangent of theta is equal to -1/2. To solve that, I have to figure out in which quadrants is tangent negative.
2 and 4.
2 and 4. I go to inverse that on my calculator. Tangent inverse 0.5 on my calculator, and I get 2656. So I have 2656 back of 180, which is 153.44 degrees. And if I subtract 2656, I get 333.44 degrees. So how many solutions did I have there? That's 5. Notice in the previous one we had 4. The one before that we had no solution. The one before that we had 2. I can't always tell you the number of solutions you're going to get. Our last 2 examples. For this one, we're going to factor it as well. We're going to factor it like it's a trinomial. I have 5 cosine and cosine. Anybody know what the other 2 numbers are going to be? Is it going to be 2 and 2, 1 and 4, or 4 and 1? If I do a 4 and a 1, it looks like I'm going to get 4 cosine right there. It looks like I get 5 cosine right there. That makes a total of 9 cosine. I solve each of these equal to 0. I'm going to start with the easier one. Cosine of theta plus 1 is equal to 0. As I subtract 1, cosine of theta is equal to -1. When is cosine equal to -1?
180.
180. Our other one, we have 5 cosine of theta plus 4 is equal to 0. I subtract the 4. 5 cosine of theta is equal to -4. And I divide by 5. Cosine of theta is -4/5. In which quadrant is cosine negative? 2 and 3. I inverse cosine of 4/5 on my calculator. I believe I get a 36.87. I will subtract that from 180, and I get 143.13. And I add it to 180, and I get 216.87. Our last example for number 10. What could you factor here?
Sine.
Yeah, just take out a sine. And you get sine of theta times tangent of theta minus the square root of 3. Our two equations will be sine of theta is equal to 0 and tangent of theta is equal to the root of 3. If you remember from your previous sheet where sine was equal to 0,
90 and 270.
that would be 1 at 90 and negative 1 for 270.
0, 180, and 360.
0, 180, and 360. And then the root of 3, the other classes, they remember this. I bet some people do here as well. Do you remember where tangent is equal to the root of 3?
Sure.
60.
Yeah, it's at 60-degree angle. So you have 60 degrees in the first quadrant, and you have 60 degrees in the third quadrant. So that's going to leave you with 60 degrees and 240 degrees. So again, 5 solutions. That's a really nice intro into solving trig equations. We do have more complicated ones to see later on. This assignment is not due on Friday, but I would encourage you to try to get this one done before Friday, just so you can, kind of solidify it in your learning.
These aren't gonna be like on our list.
They are not on your test. I chose to cover it because I think that if anything, thinking about these values can help you for your test. But yeah, so tomorrow we'll do our quarter 3 review, and then you guys got time to work on Wednesday.